Alright, so let's continue with modulation. It's been the next day. Right now, as I'm recording this, I took a quick break because it was getting quite late. So yeah, let's continue with modulation. Modulation is a topic where it's not that super easy to understand, especially if you're a beginner. So don't worry if you don't get it right away. It takes some time, some experience to really fully understand what's happening under the hood. What does sync really do? What does frequency modulation really do? But I think it's more important, especially as a musician and producer, to understand what is happening with the sound. So how is FM changing the sound? How is, I don't know, pulse width modulation changing the sound? So this is what I'm about to show you right now. And for this, let's open up we can do this in this project as well. So let's just take a lead sound. I'll create a new track right here. Should work. So let's open up Serum. And first, for you to know, modulation, as I told you in the previous lectures, is something that you can select in this drop-down menu for each oscillator right here. So when you click on this off label, you get this context menu where you can change from sync to band, PWM, which is pulse width modulation, asymmetrical, flip, mirror, remap, frequency modulation, quantize, amplitude modulation, and ring modulation. So what those all do, I will explain to you in this lecture, and we will start with a simple thing that is called sync. So when I select sync, this is the first entry in this context menu. So as you can see, nothing is happening. I just have to click this, which, by the way, this is called no window. So these three different sync modes, let's just say for now, they are kind of working differently. So they're all synchronizing, but they all work kind of differently. So let's just start with this no window sync mode. So as you can see, we have this knob right here, and as soon as I start increasing this from 1% to up to 16%, we're getting something like a repetition. So what it actually does in analog gear is it's synchronizing one oscillator to the other oscillator. And if you take, so basically what this does, let me start there at this point. When you playing a sound, as I told you in the beginning, you have a starting point, which is the phase. So when I turn the random down and set the starting point all the way to the left, every time I hit the key, and why do I have sound? I don't have sound. Why don't I have sound? Is it, okay. I thought it was because of my recording. There we go, okay, that's better. So when I turn this up, it's actually changing the phase. So when we're starting at this point, every time I press the key, it starts at the left side and goes on and on and on. So what it normally would do when I synchronize my oscillator, it would synchronize an oscillator to the other oscillator. So now they're just overlapping, of course, because we don't have this random phase right here, but nothing is happening. So when I turn up this synchronized knob in Serum, in a digital synthesizer, what it does, it actually changes, for you as a beginner, it changes the speed how those sine, or in this case, saw waves are played. This gives us this nice kind of squirky texture to the tone. So what it does, basically, what it's supposed to do is when we have a oscillator that is slightly playing out of key, let me turn this down. So it's, let's just say like 18 cents faster, because the higher the pitch, the faster the frequency, of course. And every time, so when I press the key, both oscillators start at the same point. But this oscillator B is quite a little bit faster than the first one because it's 18 cents higher. So it plays 80 cents faster the wave cycle. So when this oscillator B starts over again, this oscillator maybe only be at kind of this point. So what synchronizing does, every time one oscillator is done playing the wave cycle, all oscillators start at the same point. Meaning every time I play or hit a note and the wave cycle of one oscillator is done, all oscillators start at the same point again. Meaning it would technically look something like this. So this wave cycle is done, and this is only at this point, but there it is already starting again. Okay, so this is why we are getting more repetitions when increasing the sync knob. What the sync knob does, it actually tells this oscillator, okay, the other oscillator is a bit faster, I'm sorry. So we're getting something like this, this tone to it. That's the basic, simple explanation of what sync does. For you as a musician and producer, just think about that as it's repeating the wave cycle faster than it normally should when selecting this waveform or this wavetable. Now let's take a look at the next one, which is window a half, and as you can see, it's kind of changing the way it behaves. It still sounds similar, but if we turn this up and switch forward and back, you can see it's kind of shaped. So this is for you as a producer, it's shaping the start and the ending point, and if you go one step further, it's doing it a lot more. So this is more like a football right here, but that's basically what it's doing. Okay, so if you want to create something like you have a saw wave like this, and you want to fade those edges slightly so they are more smooth, they can, or you can use sync window, in this case window full, so you get the slight movement on the, or curving on the edges. Okay, so that's just a way you can use it. It sounds like this. So it kind of sounds like a toy synthesizer actually when you turn it up very high, and this is the way you can use it, or could use it for sounds. I think I would use sync for purposes when you create something like a lead, or when you want to make it something analog, so you can just move that. Okay, I should select something. Let's take this. You can move that. So let's take an LFO and turn this up very little. Turn it higher. So it's kind of moving in and out, so it's get this, you get this texture basically. So what we're going to do now is first delete this one and change the modulation to band. Let's start off with band plus minus, okay? So band plus minus, as you can see, it's banding, like the name says, actually it's banding the waveform. And if we are going to 0%, which is actually in the middle right now, we have the common saw wave. And if we turn this to the left side, we get a bend outwards and we get a bend inwards. So this is actually minus, this is plus. It actually should be called band minus plus because you're going from minus to plus. So we go now to band minus. I'm sorry. It's actually the other way around. So it's correct. So this is band minus, it's outwards. And band plus is inwards. So it's banding inwards, it's getting more band, and it's banding outwards, it's getting less band. So this is how you could think about that. And basically what it does, just listen to it. Of course, this is more morphing to a square wave, so we get this kind of square texture. So let me just first up that. Select a square wave right here, and let's work with that. So if we play the square wave right now, and now let's play the band minus saw, it kind of sounds similar to a square wave because it's almost, besides those rounded edges, almost there at a square wave. And if we turn this down to that, we getting a much kind of sounding weaker texture to it. So that's just because we don't have this much of a movement right here. So this first and this last third basically is no sound at all because it's almost at zero. And only this peak right here is creating a sound. And this is very short and shrink down, saw wave basically. And you can also do some variation with that just by adding, let's go to zero, oh, come on, zero, there we go, a basic LFO to that. So you get this kind of tremolo effect, and it's moving outwards and inwards and changing the sound a little bit. So let's remove that one again, and let's head over to PWM. So PWM is probably one of the most known modulation types. It's called pulse width modulation, and it actually comes from a as an analog or a synthesizer originally was analog gears, so it comes from a physics point of view, basically. So pulse width modulation is a changing current in electric circuits. And what it does is it tells a device, so in this case our oscillator, based on pulse width, when it should turn on and turn off. So let me simplify this. When we take a look at this and increase the amount of warp or of modulation, you can see we're kind of pushing the saw wave to the side, and the rest is basically zero. So nothing happening right here. It's pure off, basically. So what it does when we tell the synthesizer and give him a signal of 50%, it just tells him, okay, the first 50% should be on, the rest of the 100%, so the next 50% should be off, meaning the first half, 50%, the first half should be playing the sound, and the second half should be off. If we now change this one to a sine wave, you can see it's the same there. And pulse width modulation actually comes from the name pulse based on a square wave. So if you take a look at the square wave right here, turn down the volume so we don't hear it, you can see it tells, we should actually invert this one. So let me just do that quickly. So that's more clear. So the first half is on and then switching off, on, off, on, off. And if we set the pulse width modulation amount to 25%, it tells the oscillator, okay, 25% on, 75% off. This would be something like this, except that we should invert this again. So something like this, okay? 50%, 25%, and you can imagine if we turn this all the way to zero, it tells them, okay, 0% on, 100% off. If we turn this to 10%, 10% on, 90% off. Okay, I think you get the deal. So this is basically what happens with the saw or the wave shape, in this case, waveform, when you turn on pulse width modulation. And by the way, this amount, so 50%, is actually called, for you if you don't want to know, a duty cycle. So this duty cycle is 50% of the full wave cycle, okay? And basically sounds like this. So let's take a saw wave again, like that. And in this case, you can see it's going up again, and it's leaving it basically all the way on. And this is just because of the waveform. So this depends on the waveform. If a wave shape ends at zero, it leaves it at zero. If it doesn't end at zero, it starts, or it goes to the opposite and keeps there, so it can start from there again. So it goes down, up again, waits, and there we go, down, up again, and starts again, okay? So we can actually change this. Let me just do something like this real quick. So this is our typical saw wave, and as you can see, it's now starting at zero. If we put this down just one, you can see it's still starting at zero because starting point is still at 0, okay? So this is the reason why, or the factor where based on where the zero crossing or the zero line would be. All right, so again, as you can probably imagine, as we're having more and more no sound being created, we have a weaker signal. Okay, so you can again create some nice wobble effect. And let me just show you what you can do basically. We could, for example, map this one to there and this one to the frequency rate or the LFO rate and keep something like this. Okay, so it could be a nice effect if we want to create some sound effects or so. You can use it for this one. You can use it again for creating some analog vibe to it by using the chaos and LFO. So there are quite a few possibilities that you can make use of with PIWM. So next up we got asymmetrical, and it's kind of working the same as band plus minus. We again have plus, minus, and plus minus. What happens if we turn this all the way up? It's basically shifting the waveform. So you can kind of remember asymmetrical with shifting the waveform forward or backwards. So plus would be to the left side, and minus all the way to the right side. You can see it's not going quite close there. We're only going to minus 99% and 100%. I actually don't know why this is the case. As you can see, we got some weird artifacts there. And again, I can tell you why this is. Maybe this is just because of the UI. So there's a slight bug. You can see this. I don't know if you can see, but it's on, just zoom in or whatever. There's a slight offset right here at the zero crossing point. And if you turn this to minus all the way, it's completely straight. I think this is a UI thing. So the UI has some bugs right there. But basically what it does is just shifting the waveform, and that's all you need to know. So let's continue. And again, like, plus is only shifting in this direction and minus only in this direction, of course. Next up, we have a flip. So it may sound or look weird, but it actually isn't. What it does, it is flipping the waveform. So if we turn this all the way to 50%, there we go. The waveform is flipped. Let me just copy this one to B. There's no flip, and we turn this to like 50%. You can see it's completely inverted or flipped. We turn this up to 75%. The first part is again flipped. The same goes for 25, but in this case, the whole waveform is flipped, okay? So this waveform is the normal one, and by increasing the percentage, we are starting from left to right, flipping, 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 and again flipping in the other way around. And the reason why it flips again is just because you can create something like this or this in the opposite direction, okay? So this is basically what it does. Flipping, you can do some weird stuff with that. So let me just play that. If you want to create something like a robot or I don't know, some sound effects, that's the way to go. But you can create, if you just want to flip the waveform and you don't want to go into the wave editor or so, you can just use 50% on here and you get a flipped waveform. Or you can do some weird variation with that, or create a custom waveform if you want to create something interesting. It has some formant artifacts in it, so could be nice. The next thing is mirror. So mirrors might seem a little bit weird in the beginning, but it's actually pretty easy to understand, because if we put this to 50% as well, we can see, okay, this is the first or original waveform, and then it's repeated, but in a mirrored way. So it's basically mirroring this waveform to the right side. If we turn this to 25%, you can see it's kind of skewing this waveform to the sides. If we put this to 75%, it's skewing the waveform to the center. We can go all the way up to 100, and it's almost like the same as the 75 flip version, 75% flip version. But this is basically the concept behind mirroring. So pretty straightforward, nothing fancy there. And you can create some nice phasing effects. Yeah, can be very useful for leads that shouldn't be that clean but more aggressive. So next up we got remap. Let's skip remap for now. We get to this in a couple of seconds, but this is the more, I wouldn't say complex, but very difficult to understand. Next up we have quantize. So quantize is pretty easy to understand because it's similar to the quantize function that you would have on your MIDI notes. So if we turn this up, you can see we're getting these steps right here until we have like 100% where we don't have any steps at all. One step, there we go, come on, 2 steps, and so on. So what quantizing does, it's quantizing the steps, so the amplitude basically. So you can listen to that. It's kind of actually downsampling the sound. So this has a downsampling effect. Downsampling is something that you would hear in 8-bit music, for example. So you don't have this big range of dynamics, and this is because we have this 8-bit type of sounds. So let's take a listen. And honestly, I have no idea. As you can see, it's kind of bugging around there. When we go in the editor back, it should look like this, but as soon as I hit the key, it just goes away. So normally this shouldn't create any sound at all because it's just a straight line on the 0 line. So we shouldn't have any sound, but in fact, this should actually look something like, now you can see, so this, but inversed to right around here, only like 50% or so. So we get still a sound. And this is just because I think this algorithm that creates this visual representation of the quantized waveform is not that great working in this case. But you can see and hear what it does. This is not a thing that I would use for modulating on the go. So meaning using an LFO for that, or an envelope, because it's creating this artifacts when you move in between there. This is just a thing that I would say you just dial in and say, okay, I like this tone, I like this tone, and use it for that one, but nothing more, okay? What you could do is if you create something like a step right here, let's take just something like this. So I'm currently holding the Alt key to create those steps based on the grid. And let's do something real quick like this. Give me a second, I'm done. And right here, so this is pure steps. And if we put this through there, it doesn't work, of course, but if you put this to a quarter, it would kind of work. We still have this artifacts, but this could be a nice arpeggiator if you just process it a little bit in the afterwards. And we could also put this envelope LFO to the semi pitch. So maybe not that much, but maybe like this. And then just use some compressor. Maybe not that much. Yeah, I don't need caps lock right now. So that could be a nice ARP that you want to use for, I don't know, game music or so. can also put this to panning. I mean, if you want to do something like this, why not, right? So you have the possibilities to create some cool game sound effects with that one. That could be pretty well fitted for a sci-fi, I don't know, game or something like that. Yeah, you can do some creative stuff. Like I said, this is sound design, so it's not only creating leads or chords for music production, but you can also create some crazy stuff, especially with modulation for sound effects, game music, ambient textures, or something like that. So there are lots of possibilities right there. So let's continue. Let me just remove that. There we go. Let's continue with FM. So now it's getting a little bit tricky, actually. Let me reset that. Oh, sorry, I should. There we go. And deactivate all those effects. FM stands for frequency modulation. So before we go to FM, let's start with AM, the second entry. And this is because AM stands for amplitude modulation. In this case, it's saying amplitude modulation from B. So what does that mean? Let me give you an example. Let's take an analog sine wave and turn down the volume. So when I deactivate oscillator A, you won't hear anything because we don't get any volume out of that, okay? Just so that you make sure to understand that this one isn't for any sound. This won't create any sound. So what I can do now when I increase the amount of amplitude modulation from B, it's kind of doing nothing. And this is just because we have those two oscillators at the same pitch. Because what it does, it uses the amplitude, so high amplitude, negative high amplitude, positive high amplitude, negative high amplitude, and to modulate the amplitude of this oscillator. So when we now would increase the speed of that, talking the pitch, and increase it now, we are getting this slight movement in amplitude, and you can completely refer to that because it's moving up and down, and this is because this oscillator B is moving faster than the first oscillator. And if we use something like in Octafier, you can hear there is a different movement in there, and based on this frequency, and because this is one octave higher and only 7 semitones, it's getting a different sound hit. It feels like those waveform is mixing in there, and that's actually quite correct because this amplitude is moving quite fast, but you don't hear this fast movement in the amplitude because it's moving so fast that is just, you get some phase shifting right there. So this is just because normally it would move identical to this waveform, but because it's so fast, we just have this +7 semitones moving up and down, and this +1 octave, because it's the same key as this one, just 1 octave higher, moving or modulating the sound in a way that it actually changes the sound. Okay, so if we turn down, let me set this to 0. Okay, you can hear there is a different modulation tone to pretty much every different pitch. Okay, so that's basically what AM does, amplitude modulation. So if we go now to FM modulation, this modulation is based on the frequency that is played. So not the amplitude. It's not following the amplitude, it's following the frequency. So let's take a listen to that. Okay, so that is very difficult to understand if you're a beginner. Let's just go with that FM creates some metallic textures, and depending on the waveform that you choose, it plays into the sound, okay? So this is the thing that I can't give you like something, a value that you should set that works always. It completely depends on the key that you're playing. It depends on the waveform, the detune, the waveform of the other oscillator, the pitch of those two oscillators. But a thing or a value where we could go to start off from is somewhere around 60%. Okay, so this is one way you can use it. And if we take a look at ring modulation now, ring modulation, actually, to give you a technical explanation, ring modulation is kind of based on the amplitude, but it's actually multiplying the modulating oscillator with the modulated oscillator. And you can get something like a bell character out of that if you apply that correctly, but you can create some weird sounds as well, of course. With this too. So we turn down this one. You can probably already hear this this bell sound in there. Right? So just remember for yourself as a music producer, FM kind of creates a metallic sound, ring modulation, RM creates something like a bell sound, and AM is just creating something like a tremolo effect. So you get a vibrato that is moving the volume, the amplitude up and down based on the second oscillator. So those are the three main modulation types that I use. I sometimes use something like sync to create this analog type sound by moving this this sync based on the chaos knob or chaos functionality in Serum. But those are the basic explanations for modulations. If you don't understand those right away, don't worry, it's quite complex to understand them, how they actually work under the hood, how it technically works. But it's more important for you to understand what sound you can create with these modulations and how to apply them so you get something like a nice, good sounding sound, not a lot of artifacts that destroy the sound. But you can use something like FM with 60%, right about 60%, to create some metallic sounds, ring modulation for bell sounds, AM to get the tremolo, and sync, bend, PWM, and asymmetrical to create some analog type sounds, and flip, mirror, and quantize to create something like a bit sound. And to go back to Remap for now, Remap is a custom modulation type. So if we take a listen to that, this is let me close that for now, and deactivate the filter, deactivate this one, and set this to default. So when we click on this arrow, not arrow, but pencil right here, you can see we're getting a completely brand new shape window. And I'm sorry, this window actually allows you to modulate the waveform based on your shape that you're drawing right here. So if I turn this down, you can see we're kind of skewing again this waveform in the left and the right direction, but also kind of changing the move or the behavior of the curve. So before that, it's just a straight linear line, and now it's kind of moving into an exponential way, and it's curved outwards or to the right, and when we turn this up, it's curved to the left, following the shape right here. If we would now, and by the way, when I hit Control and click on these curving knobs, you can reset them. If I would now add like another knob right here, you can see we get this extra point where it's going with this, like how it's called, we're going this steep, and then it follows a much higher or steeper curve, and this is going up there again. So you can say, okay, let's go from 0 and then only go up. And it's also skewing this in the direction. So when you pull this knob to the right, it's skewing the waveform to the right. If you're taking this one, it's skewing this to the left. Okay, so by that you can actually, it's kind of, you have to try it out for yourself and get a feel for that, how it works. It would be too long now for you to explain exactly how this mathematically, or in this case coding based, works. But you can kind of change the waveform based on these lines that you can create, and you can create some cool. Now I should create something like this, and then do that, and do that again, and you get some nice shifted and curved saw wave, for example. So this is a way that you can use that. I can also use the rasterize function right here when I hit or hold down the Alt key. And as you can see, when I move that above the center line, we are creating a spike right there. And then we're going to the opposite side. So if we put this right here and add something like here, then we're creating the complete opposite value. So this is 0 up all the way to 100, and then minus 100 all the way up to 0. This is the way how I would explain it in a simple way. It's quite difficult to understand when you're a beginner in the first place, but you get the hang of it as soon as you try it out a little bit for yourself. By double clicking on the knobs or points, you can delete them and create something on your own if you want to. It's actually quite intuitive. Oh, come on, there we go. Where, by the way, with no, it's not resetting. It's just, but you can, when you want to set this back to 0, you can just hit the Alt key and draw or drag this knob to the center because it's snapping to the center. And yeah, that's basically how this remap works. You have actually the possibility to use custom shapes right here. So you have the basic shapes that are included in the LFO as well. So something like a sine wave that's creating something like this. You have something like a triangle, which is the basic LFO shape, which is creating the mirror function. So this remap is basically a way where you can create your own custom modulations. And as you can see, the mirror function is something like this remap right here, okay? So you have 4 different remaps that you can save for yourself. All those remaps are working in slightly a different way. So you get 4 remaps in this case, you get 3 remaps in this case, 2 remaps and only 1 remap, okay? No, that's mirror, sorry. 2 remaps and 1 remap. So this is just the amount of remaps that you have based on your custom shape that you're drawing. So those are all those different modulation types. If you get any questions, let me know. And if you are interested in a more comprehensive video about those mod types, let me know as well, and send an email to feedback@feeltymusic.com and let me know. And you can also go to YouTube for yourself and Google for Pulse with Modulation or Sync or FM, and you will find a ton of different videos and blog posts about how those types work, how those modulations work, what sounds you can create with that. So this is a lot experience in there, and yeah, you can learn from that very well. Okay, so now we're done with the basic explanation of modulations, and the next section, or next lecture, we will continue with the velocity and note control.